You ever stand next to one of these things? It's like being next to a building that breathes. Steam locomotives, they weren't just machines, they were beasts of iron and fire. Forged in the heart of the Industrial Revolution, these behemoths hauled goods and people, shrinking distances and connecting nations. They were the lifeblood of a new era. These weren't just trains, they were symbols of progress. The sight of a steam locomotive, smoke billowing, pistons pumping, wheels churning, it meant something. It still does. It spoke of power, of ingenuity, of man's ability to harness the raw forces of nature. And believe me, there's nothing raw like the power of steam. But how did they work? How did these mechanical marvels actually move? Well, it all starts with a simple element, water, and a whole lot of heat. You see, when water gets hot enough, it turns into steam. And that steam, my friends, is where the magic happens. It's all about pressure. That steam wants to escape, wants to expand, and when we harness that pressure, direct it just right, we can make it do some pretty incredible things. We can make it move mountains, or at least pull a train full of them. Now let's break down how this whole steam thing actually works. Imagine a pot of water on a stove. As the water heats up, you start to see bubbles. That's steam trying to escape. Now, put a lid on that pot. The steam builds up, creating pressure. That pressure is what we're after. In a steam locomotive, that pot is called a boiler. It's a massive steel tank, built to withstand incredible heat and pressure. Inside the boiler, water is heated to a boil, creating steam. But this isn't your grandma's tea kettle. We're talking about steam under immense pressure, hundreds of pounds per square inch. This high-pressure steam is the engine's lifeblood. It's what makes the whole thing go. But how do we get from steam to motion? That's where the real ingenuity comes in. We channel that steam, direct it through pipes and valves, and use it to push on something called a piston. Think of a piston like a plunger in a bicycle pump. As the steam pushes on the piston, it moves back and forth within a cylinder. This back and forth motion is the key to everything. It's the raw power that will transform into the locomotive's iconic chug. Let's talk about the heart of the beast, the firebox. This is where the real dirty work happens. Imagine a giant steel box, open on one end, that's your firebox. Inside, a roaring inferno rages, fueled by tons of coal. A fireman shovels coal into the firebox, keeping the flames dancing. It's hot, dirty, back-breaking work. The heat from this inferno is intense. It radiates outwards, licking at the steel walls of the firebox. But these walls are no ordinary walls. They're surrounded by a jacket of water, the boiler. The heat from the firebox transfers to the water, turning it into steam. Remember those pipes and valves I mentioned? They snake through the boiler, carrying the high-pressure steam away from the firebox. It's a delicate dance of heat and pressure, carefully controlled to prevent catastrophe. Too much pressure and the whole thing could blow. And believe me, that's not something you want to be around for. That's why these locomotives have safety valves, pressure release systems that prevent a catastrophic explosion. It's a dangerous job keeping these beasts running, but somebody's got to do it. Section 4, Pistons and Cylinders, the might of steam. Now that we've got our high-pressure steam, let's talk about how we put it to work. This is where the pistons and cylinders come in. Picture a large metal cylinder, closed at one end, with a piston that can slide back and forth inside. The high-pressure steam from the boiler is directed into the cylinder, pushing against the piston. This force drives the piston back, like a giant's fist. As the piston moves, it turns a crankshaft, converting the linear motion into rotary motion. But the cycle's not over yet. Once the piston reaches the end of its stroke, a valve opens, allowing the used steam to escape. This escaping steam creates the iconic chuff sound of the locomotive. It's the sound of power, of raw energy being released. Meanwhile, fresh steam is directed to the other side of the piston, pushing it back in the opposite direction. This back and forth motion, repeated hundreds of times a minute, is what drives the locomotive forward. Section 5, Wheels in motion, chugging down the tracks. So, we've got our pistons pumping, our crankshaft turning, but how does that translate into actual movement? This is where the driving wheels come in. These massive steel wheels are connected to the crankshaft through a series of rods and linkages. As the crankshaft rotates, it turns the driving wheels. These wheels grip the rails, propelling the locomotive forward. The faster the pistons pump, the faster the wheels turn, and the faster the locomotive goes. And there you have it. The magic of steam, transforming heat and water into motion. It's a symphony of fire and steel, a testament to human ingenuity. Next time you see a steam locomotive, take a moment to appreciate the intricate dance of energy and engineering that makes it all possible.